Hello and welcome back to our video. We are searching a new data model where we are studying a new case scenario about data relief centers and disaster information. Here, me and my team, my name is Kamil Abuelgasim. I'll introduce you to the case scenario, an overview of the whole project goals and the design system, followed by my teammate Kelvin, who will explain the business rules for this case data model, followed by the ERD diagram, which will be presented by a two-parter, Nay and Michael Rafael, which lastly is concluded by the SQL code that will be presented by Dan and Lim. Okay, let's get into it. Basically, our case scenario for this data model. Let's begin with the main goal. Our main goal for this project was to design a centralized database system that can not only support the disaster relief centers, but also the emergency response operations in a whole, in a very structural and efficient way. Now, specifically, our goals in this project is as I've said before, decentralized incident information, the support structured deployment, the management of the evacuees, and the tracking of the supplies and the aid distribution. Now we have an overview of project goals. We continue to why we continue to discuss our design choices and why we actually chose these design choices. To achieve these goals, we had several important database design choices. First, we designed our core design was the incidents. The incidents is actually our core entity in the system. Every disaster is locked as an incident with attributes such as disaster type, location, and the severity level of the set disaster. Second, Secondly, we have assigned the volunteers directly to the incident or relief centers, where we introduce the response teams and made a very structural way of handling the distribution system for the disasters. Okay, now we have gotten into the project goals and the design choices. We could proceed with the business roles, which will further be explained by my teammate here, Kelvin.
Thank you, Kamil. For our disaster relief and emergency response system, the business rule defines how incidents, teams, people, and resources interact in real life. When a disaster occurs, an incident is created in the system. Each incident has a clear status and can have multiple response teams assigned to manage different aspects of the situation. These teams are always linked to a specific incident, have a designated leader, and may be assigned vehicles to support their operations. Volunteers play a key role in disaster response. Only individuals aged 18 and above can register as volunteers. Volunteers do not need to be deployed immediately, and they can be deployed multiple times to different response teams. Each deployment is recorded with a deployment date, and volunteers may have multiple skills, which allows the system to match them to suitable tasks. Evacuees affected by an incident are registered and assigned to relief centers. Each evacuee is linked to the incident that caused their displacement. Relief centers have a maximum capacity, and the system ensures that this capacity is not exceeded. The system also manages supplies and donations. Supplies are distributed to relief centers through recorded distribution events, with quantities and dates tracked to maintain accurate inventory levels. Donations are linked to specific incidents, and they can be monetary or physical, and they must have their estimated value recorded. Overall, these business rules ensure accurate tracking, data integrity, and efficient coordination during disaster response operations. With that being said, I would like to pass it to Nay to talk about the ERD diagram.
Okay, thank you, Calvin. For the ERD part, there are going to be two parts. I'm going to talk about the first part, and then my friend Michael going to be talk the last. Okay, like Calvin said in the business rules, we put accordingly to the business rules. The first one is like volunteer skill, which link to the volunteer by volunteer ID, and the relation is like many to one, many or one to many or one. And another one is volunteer to the volunteer deployment, which deploy the volunteer to the disaster, which link to the response teams, responding through the team ID, and then which deploy the volunteer to the incident happens and to evacuate the people to the disaster based on the disaster type, and then also the release center. Okay, I think that's all. Next, Ike gonna talk about.
Thank you, Nate. Now, for now, I will continue the second part, starting from the response team. For the response team, it is connected with vehicles assigned as a many-to-many relationship. And for vehicles that are assigned, they're connected to vehicles by a relationship of many to one. And if we go back to the incident, when it comes to the connection between incident and evacuees, the relationship is a 1 to 0 or many, which is an optional one. And then the connection between evacuees and relief centers is a many to one. And of course, the connection for the relief centers and the distributions is a 1 to many. And for the distributions to supplies connection of a relationship is a 1 or many to 0 or many. And now we'll leave it to Lim Jien Huong and Thant Zaw Aung for the next part.
Okay, hello, my name is Jien Huong. I'll be showing on the SQL script, right? As for the first part where you drop the table with cascade constraints is to prevent any integrity error when you delete the table, right? Now moving on, you have to create the table disaster. And as you can see here, you have the disaster ID and the name, and it cannot be empty. And there's the table for incidents, where it refers back to the disaster ID, and with the incident ID as the primary key. The rest are not null, which means they cannot be empty as well. And here you can check if the severity level is at what level. Then you have the status, whether they're active, contained, resolved, or under assessment. And there's the incident date. As you can see here, it refers back to the disaster, right? And the next one, you have the relief centers, where they will check, they have the center ID, and they also check on the current occupancy and whether it has reached the max capacity or not. And for the next one, you have the evacuees. It refers back to the relief centers, right? Where they will be used, where the evacuees will be sent to the relief centers and see where they're assigned as well. Now for volunteers will have their own ID as well. And as for the rest of the detailed information, they cannot be empty. Then you have the volunteer skills to see, which volunteer has what sort of skill, and it refers back to the volunteers, the volunteer ID, right? And then there's the response teams where, they will have their own ID and they have their own leader name, but they will be assigned to the incident, which you have to refer back to the incidents for the foreign key of the incident ID. Then you have vehicles where they will be assigned to teams, which will be again referred back to here, where they will have to refer to the vehicle ID and the team ID. And the next one, where you have volunteer deployment. Volunteer deployment will have their own deployment ID, but you refer to the volunteer ID and the team ID to see which volunteer will be assigned to which team as well. Then you have the supplies where, information must not be empty, and the supply ID is as the primary key, right? Then you have the distribution where the distribution as its own primary key, then it refers to which supply is being sent to, as mentioned, and the center it's being sent to. A quantity distributed and distribution date must not be empty. And yeah, that's pretty much it for distributions. Then there's the donation where, whoops. There's a donation where it has its own donation ID, but it refers to the incidents as to see which donation is being sent to what sort of incident as well, right? And as for information, everything should not be null. It's like, okay. Now I'm going to run the SQL script. Okay, as you can see here, it is successful with 0 errors, right? Now I'm going to show the table in the detail. So here is the incident table, disaster, center, volunteer. Volunteer deployment has already been processed. There's a team, then there's the supplies, distribution, donation, incident, vehicle, assignment, volunteer. Everything is all been created successfully. I'm now done and I'll pass it over to my other teammate.
Thank you, Jien Huong. Now I'll be talking about the queries. The first query will be including the supply distribution, and we use left auto join to include relief centers that have 0 distribution. It is for resource monitoring. It identifies relief centers that have never received supplies and centers at risk of being overlooked during disaster response. So if we run it, you can see the center ID, center name, and the distribution. And the second one is to count total supplies distribution for each disaster type, and it joins 5 tables and uses group by to aggregate distribution activity for each disaster type. The main idea is to support strategic planning by showing which disaster types consume more resources. So it helps allocate the supplies for future incidents and identify supply disaster that may be under-supported. So if we run it, you can see the disaster name and the total distribution that had done. The third query is to find volunteers with first aid skills that is deployed within the last 30 days. This query use like for string pattern matching and admin for data filtering. Date filtering. It is to identify active medical volunteers, avoid assigning the inactive or unavailable staff, and to improve response speed in medical emergency. So you can see the full name, the skill, and the deployment date. The fourth query is to identify high risk or active incidents. We use or and and logic to focus on incidents that are both severe and currently active, supporting emergency prioritization. It is to highlight incidents that require immediate attention, prevent resources from being wasted on resolve incidents, and allow command teams to focus on more life-threatening situations. So if we run it, you can see the incident ID, the location that happened, the severity level, and the status. So the fifth one is to find volunteers assigned to relief center with above average occupancy by using 3 nested queries. It is used to identify volunteers working in overcrowded environments, and it also used to prevent staff burnout and decide where additional volunteers are needed. So these are the volunteers that are overworking right now. So the last one is where we answer the question where we include time-based filtering, aggregation, and correlation between centers and volunteers. It is to know which centers are
under the heaviest logistical load and which volunteers are most heavily rely on. It is to help make sure volunteers' workload are balanced and also identify crucial relief centers and data-driven decisions on resource and manpower distribution. That's it for my part. Thank you for watching.